The Earth's magnetic North Pole has always been a bit of a wanderer. Since its discovery in 1831, explorers and scientists have tracked its journey. For much of the 20th century, the pole moved at a steady pace of about 10 kilometers per year. However, in the past few decades, this slow drift has turned into a gallop. By the early 21st century, the pole's speed had increased to a remarkable 55 kilometers per year. The magnetic North Pole's path has taken it from the Canadian Arctic towards Siberia. This shift has significant implications for everything from military operations to animal migrations. Scientists are trying to understand the forces behind this acceleration. These changes are connected to the molten iron and nickel in the Earth's outer core, responsible for generating the geomagnetic field. The Gakkel supervolcano is not a name that many people are familiar with. Hidden beneath the icy waters of the Arctic Ocean, this geological giant has kept a low profile. However, the magnetic North Pole's rapid movement directly towards it has brought it into the scientific spotlight. The trajectory of the magnetic North Pole towards this supervolcano is both fascinating and alarming. The Gakkel Ridge, a mid-ocean ridge in the Arctic Ocean, was known, but the supervolcano underneath it was only discovered recently. The magnetic North Pole's path aligning with the Gakkel supervolcano raises many questions. Scientists are now racing against time to understand the potential risks and to monitor any changes closely. The Gakkel supervolcano lies beneath the thick ice of the Arctic Ocean, part of the Gakkel Ridge. The ridge itself is a divergent tectonic plate boundary, where the Eurasian and North American plates are slowly moving apart. This underwater mountain range stretches for 1,800 kilometers, but remains one of the least explored regions on Earth. The supervolcano was discovered in the early 21st century through deep-sea expeditions. Using advanced sonar mapping and robotic submersibles, scientists identified the massive caldera. The Gakkel supervolcano is particularly intriguing because it is located in one of the most remote and inaccessible parts of the world. The caldera spans approximately 50 kilometers in diameter, indicating the potential for large-scale volcanic events. The current trajectory of the magnetic North Pole towards this supervolcano adds another layer of complexity to an already fascinating geological puzzle. Understanding why the magnetic North Pole is moving so quickly towards the Gakkel supervolcano requires a dive into the Earth's core. The Earth's magnetic field is generated by the movement of molten iron and nickel in the outer core. These movements create what scientists call magnetic flux lobes, regions of intense magnetic activity. Changes in the strength and distribution of these flux lobes have been observed. These changes are believed to be driving the accelerated movement of the magnetic North Pole. Essentially, the magnetic field is shifting and reorganizing itself, and the pole is following these changes. The exact cause of these changes in the magnetic flux lobes is still a subject of research. The pole's current trajectory towards the Gakkel supervolcano is a prime example of this complexity. The intersection of the magnetic North Pole's movement and the Gakkel supervolcano has opened up new avenues of scientific inquiry. One pressing question is what the implications of this convergence might be. As the magnetic North Pole moves closer to the Gakkel supervolcano, it could influence how solar energy is distributed in the region. This could affect the temperature and pressure conditions, potentially triggering volcanic activity. The rapid movement of the magnetic North Pole has already required adjustments to navigation charts and systems. If this movement continues towards the Gakkel supervolcano, it could necessitate further changes, impacting aviation, shipping and wildlife migration patterns. The potential risks make it a high priority for further study. The August 17th, 2024, solar storm was a stark reminder of the power of electromagnetic activity. This solar storm caused widespread disruptions to satellite communications and power grids. It provided valuable data on interactions with Earth's magnetic field. Scientists observed unusual magnetic activity near the Gakkel supervolcano. The lessons are clear. We need to be prepared for the unexpected. The magnetic North Pole's accelerated movement towards the Gakkel supervolcano is a fascinating and potentially alarming development. It underscores the dynamic nature of our planet. Monitoring the Gakkel supervolcano is now more important than ever. The potential for significant geological and geomagnetic events is increasing. Scientists must continue to study these phenomena closely. The potential global consequences of a major eruption cannot be overstated. By staying vigilant and investing in research, we can better understand these risks.